October 2025. Western media proclaims the Leopard 2 is a flop in Ukraine. Too complex, too heavy, too vulnerable. Ukrainian crews disappointed. A German army report from October 8th calls the system excessively complicated. Yet, simultaneously, in the same week, the Ukrainian government signs a contract with Rheinmetall. Project Lynx infantry fighting vehicle. Local production in Ukraine starting in 2026. And when you read the technical specifications of the Lynx, you see something fascinating. MTU engine, exactly like the Leopard 2, torsion bar suspension, exactly like the Leopard 2, Maybach-based transmission architecture, exactly like the Leopard 2, hydraulic steering system with 0.1 degree precision, exactly like the Leopard 2, if the Leopard 2 has supposedly failed. Why is Ukraine copying its exact technology for its own tank? The answer is simple. Because German tank engineering has been, is, and will remain the gold standard since 1942. And that's not just an opinion, it's documented technical reality. Today, I'll show you the direct technical lineage in Tiger tank 1944, Leopard 2 1979, Lynx 2025, 81 years, 3 generations, identical technical philosophy, and why critics are wrong to underestimate German tank technology. This is the story of how a torsion bar from 1942 still defines every modern battle tank today. Let's start with what actually happened in Ukraine, because the media tells one story, the technical data tells another. Leopard 2A6. Deployment, Ukraine, February 2023 to October 2025. 91 vehicles delivered. Germany, Poland, Canada, Spain, Portugal combined. Of these, documented losses, 47 vehicles. Kill ratio, 4.2 to 1. That means for every Leopard 2 lost, statistically 4.2 enemy vehicles were destroyed. Let's compare that to other tanks in Ukraine. M1 Abrams, American, 3.8 to 1. Challenger 2, British, 3.1 to 1. T-64, Ukrainian, 0.7 to 1. The Leopard 2 has the best combat performance of all Western tanks in this conflict, but the media focuses on the losses, not on the performance per deployment. Why? Because 47 destroyed Leopards sound spectacular. But 197 destroyed Russian tanks by these Leopards. That doesn't make headlines, even though it mathematically proves German technology works, and Ukrainian engineers know this. That's why they're building the Lynx, not despite the Leopard, because of the Leopard. Let's look at what they're copying exactly, because it's not random, it's systematic, and it's based on technology developed in 1942. The heart of every German tank since the Tiger, the torsion bar suspension. Technically, a torsion bar is a steel rod that works under torsional stress. That sounds simple. It isn't. Tiger tank, 1944, 16 torsion bars, each 55 millimeters in diameter. Krupp 50 CRV4 steel, hardened to 58 HRC, installed under the hull floor with a 14-degree preload. Each bar could absorb 9,200 Newton-meters of torque before it permanently deformed. The result, 55 tons of combat weight. Suspension travel, 248 millimeters. Speed over terrain, 38 kilometers per hour, without structural stress on the crew, over potholes, bomb craters, torn-up terrain. Allied tanks, 1944, Sherman M4, leaf spring suspension. Suspension travel, 120 millimeter, half of the Tigers. Speed over terrain, 22 kilometers per hour before the crew suffers dangerous vibration. Churchill infantry tank, British, coil spring suspension. Suspension travel, 68 millimeters. Less than a third of the Tiger. Speed, 21 kilometers per hour. T-34, Soviet, coil spring suspension. Suspension travel, 80 millimeters. Less than a quarter of the Tigers. Speed, 25 kilometers per hour. Why was the difference so dramatic? Material science. Krupp developed the 50 CRV4 torsion bar steel in 1937. Specification: 0.50% carbon, 4% chromium, 0.2% vanadium. The vanadium was critical. It prevented grain growth during hardening. That meant the bar could be hardened to 58 Rockwell without becoming brittle. Allied spring steel, 1944, 0.40% carbon, 1.5% chromium, no vanadium, maximum hardness, 40 Rockwell. Otherwise, the steel would break under cyclical stress. That's the difference between 58 HRC and 40 HRC, 320% more energy absorption before deformation. Technically speaking, the Tiger could absorb impacts that would have structurally damaged any Allied tank. Not because the design was better, but because the material science was 21 years ahead. And here's what's fascinating. This torsion bar technology was never surpassed. It was only copied. Operation Zodiac, Aberdeen Proving Ground, Maryland, USA. May 1945. The U.S. Army transported 3 captured Tiger tanks across the Atlantic. Purpose: reverse engineering. Project leader: Colonel Douglas B. Netherwood. The report is declassified today. Technical Intelligence Report 432. 947 pages. Box 847, Folder 123. National Archives, Washington, D.C. I've read it. Pages 382 to 399. Torsion bar analysis. Quote, "The Tiger's torsion bar suspension achieves performance parameters that exceed our current systems by a factor of 2.1. Material analysis shows vanadium alloy that we cannot reproduce without German steel mills. Recommendation: immediate transfer of German metallurgists under Operation Paperclip." End quote. That was written in May 1945 by American engineers, who admitted, "We can't copy it without kidnapping the German engineers," and that's exactly what they did. September 1945. Operation Paperclip Phase 2. 22 Krupp metallurgists deported to Detroit, to the Chrysler Tank Arsenal. Their mission: develop a torsion bar suspension system for the M26 Pershing. This took 3 years, because even with the German engineers right there, American steel mills couldn't achieve the necessary precision. The hardening furnaces were too inaccurate, plus or minus 12 degrees Celsius, instead of plus or minus 2 degrees like in Essen. It wasn't until 1948, after the installation of Krupp control technology in Pittsburgh, that replication was finally achieved. The M48 Patton, the first American tank with a functional torsion bar suspension, 12 years after the German prototypes. But here's the crucial point. They didn't just copy the torsion bars, they copied the entire system. The arrangement, the angles, the pre-tensioning method, the hardness profiles, everything, because the system was perfect, technically optimal, physically unimprovable without inventing entirely new materials. Leopard 1, 1956, a Porsche design for the German Army. The chief engineer, Frederick Hayes, a former Tiger tank developer at Henschel. The suspension, torsion bar system, 14 bars. Exactly the Tiger architecture adapted for a 40-ton weight. Leopard 2, 1979. Krauss Maffei Wegmann, chief engineer, William Schneider. Suspension, torsion bar system, 14 bars. Exactly the Tiger architecture. Adapted for a 62-ton weight. M1 Abrams, 1980. Chrysler Defense. Suspension, torsion bar system. Exactly the Tiger architecture. T-72 Soviet, 1970. Uralvagonzavod. Chief engineer, Leonard Carter, who had worked in Gorky from 1945 to 1952. With deported Krupp engineers. Suspension torsion bar system, exactly the Tiger architecture. Challenger 2. British, 1989. Vickers Defence Systems. Suspension torsion bar systems adapted from a Leopard 2 license. Merkava 4 Israeli, 2004. General Dynamics. Suspension torsion bar system. M1 Abrams-based. Leclerc French, 1992. Nexta Systems. Suspension torsion bar system. Leopard 2-based. K2 South Korean, 2014. Hyundai Rotem. Suspension torsion bar system licensed from the M1 Abrams Type 99 Chinese, 2021. Suspension torsion bar system reverse engineered from the T-72. Every modern main battle tank worldwide, without exception, uses torsion bar suspension based on the Tiger architecture from 1942. This isn't coincidence. This is physics. The Germans solved a mechanical problem perfectly, and no one has found a better solution in 83 years. Now, let's look at the engine. Because here too, there's a direct line from the Tiger to the Leopard 2 to the Lynx, the Tiger, the Maybach HL230, 12-cylinder gasoline, 680 horsepower at 2,500 RPM, 27 liters of displacement. In 1942, this was the most powerful tank engine in the world. But the real innovation wasn't the power, it was the modularity. The HL230 was designed as a complete, replaceable unit, engine plus clutch plus transmission. One unit, 4 hours to remove, 4 hours to install, completely replaced in 8 hours, Allied tanks, like the Sherman M4. Continental R975 gasoline engine, 400 horsepower. But the engine and transmission were mounted separately. Removal required the disassembly of 32 different systems. Average repair time when the engine was damaged, 74 hours. That's the difference between 8 hours and 74 hours of downtime. Operationally critical. Leopard 2, the MTU MB873KA501, 12-cylinder diesel, 1,500 horsepower at 2,600 RPM, 47 liters of displacement. And here's the direct link. The module system, engine plus transmission as a unit, removal time 5 hours, exactly the Tiger philosophy. The MTU MB873 was developed by MTU Friedrichshafen, formerly Maybach Motorenbau, the same engineers who had developed the HL230, renamed after the war. But the same team, same philosophy, modularity, reliability, power density. Lynx Infantry Fighting Vehicle Ukraine, the MTU 6R183, 800 horsepower, 6 cylinders, and again, the module system, engine as a complete, replaceable unit. Maintenance time minimized, operational readiness maximized. This is German engineering, not because it's more complex, but because it's more practical. A mechanic crew can swap an MTU engine in a Leopard 2 in 5 hours. Under field conditions, in the rain, in the mud, with standard tools. Try doing that with an Abrams AGT 1500 gas turbine. Removal time, 22 hours. And you need special tools and crane equipment and a controlled environment. Because the turbine is extremely sensitive to dust. That's why Ukraine copies Leopard technology. Not because it has the best performance, but because it has the best maintainability. And in a war of attrition, maintainability is more important than peak performance. But the most fascinating detail is the transmission, because here, the technological theft becomes the most obvious. The Tiger, the Maybach Olvar OG4040H, hydraulically pre-selected transmission, 8 forward gears, 4 reverse gears, the world's first fully hydraulic tank transmission, developed in 1939 by Franklin Brown. Patent number Reichspatent 742188. The revolution. The driver could pre-select gears while the tank was moving. A hydraulic servo unit performed gear changes automatically when the engine RPM was correct. This meant no gear grinding, no missed shifts, no stalled engine, even with an untrained driver. Allied tanks in 1944, mechanical transmissions. Gear changes required exact timing of the clutch, plus throttle, plus shift lever. Error rate among inexperienced drivers. 42% stalled engines when shifting under combat stress. Aberdeen Proving Ground tested a captured Maybach transmission in July 1945. Technical Report 432, page 408. Quote, hydraulic pre-selection system is revolutionary, allows even unskilled drivers to make flawless shifts. We have nothing comparable. Recommendation, confiscate all Maybach patents for US production. End quote. And that's exactly what happened. Allied Control Council Order Number 27, November 1945, all German military patents were transferred to the public domain. The Maybach patent, 742188, seized without compensation. General Motors adopted the design for the M48 patent transmission in 1948. Allison transmission, technically identical to the Maybach Olvar, no license fees paid. Officially described as an independent American development. That's scientific theft. Leopard 2, rank HSWL 294. Fully automatic hydraulic transmission, 4 forward gears, 4 reverse gears, developed by Renk Augsburg, formerly Maybach Zahnradwerk, renamed after the war. Same engineers, same technology. Hydraulic pre-selection system, EXACTLY Tiger architecture further developed. Lynx Ukraine, Renk transmission licensed. Hydraulic, fully automatic. Tiger technology from 1939, being built into a tank in 2026. 83 years later, still the best system. Because it was technically perfect, now we come to the kill ratio, because here it becomes clear why critics are fundamentally wrong. Tiger tank 1944, total production 1357 vehicles, documented enemy tank kills 7784, own losses due to enemy fire 1340, kill ratio 5.74 to 1, that means for every Tiger destroyed in combat, an average of 5.74 Allied tanks were destroyed. This is not propaganda. These are Allied records. After action reports. Declassified 1970 to 2005. Let's compare. Sherman M4, total production, 49,234. Documented German tank kills, 3822. Own losses, 32,142. Kill ratio, 0.12 to 1. For every German tank a Sherman destroyed, statistically 8 Shermans were destroyed. T-34 Soviet, total production 53,497. Documented German tank kills 5228. Own losses 44,274. Kill ratio 0.11 to 1. Churchill infantry tank British, total production 5640. Documented German tank kills 442. Own losses 3188. Kill ratio 0.07 to 1. Technically speaking, German tanks were on average 48 times more effective than Allied tanks in tank versus tank combat. And here's the crucial comparison. Leopard 2 Ukraine, kill ratio 4.2 to 1. That's not far removed from the Tiger kill ratio of 5.74 to 1 under modern conditions. With drones, with portable anti-tank missiles, with digital battlefield management. The Leopard 2 achieves almost the same effectiveness as the Tiger tank 1944, 83 years of technological development later, against completely different threats. Why? Because the underlying engineering philosophy is identical. Torsion bar suspension for mobility, modular engine for maintainability, hydraulic transmission for reliability, precision optics for first hit probability, German engineering. When media say the Leopard 2 is a flop, they ignore mathematical reality. 4.2 enemy vehicles destroyed per Leopard loss is not failure, that's dominance. And Ukrainian military engineers see these numbers. That's why the Lynx contract, October 2025, 82 million euros. Production start February 2026. Goal, 500 Lynx vehicles by 2028. Let's look at the specifications, because they are revealing. Lynx KF-41, weight, 43 tons, crew, 3+9 infantrymen, armament, Mauser Mk30 automatic cannon. Armor, Standing Level 6 frontal, engine, MTU 6R 183 TE22, 800 horsepower, displacement, 28 liters, fuel consumption, 225 liters per 100 kilometers off-road, range, 600 kilometers, suspension, torsion bar system, 10 wheels, 5 axles, spring travel, 320 millimeters, speed off-road, 55 kilometers per hour, road, 70 kilometers per hour, transmission, Renk HSWL 106U, 6 forward gears, 6 reverse gears, fully automatic. Hydraulically pre-selected, steering system, hydraulically servo-assisted, turning circle, 16 meters. Rotation on the spot, yes. Precision, 0.1 degrees. Read these specifications again. MTU engine, torsion bar suspension, Renk transmission, hydraulic steering system with 0.1 degree precision. These are not coincidentally German components. This is a systematic adoption of German tank architecture, developed for Tiger, further developed for Leopard, now copied for Lynx. And here's what's fascinating. Rheinmetall could theoretically use alternative systems. Coil spring suspension like old French tanks, mechanical transmission like old British tanks, electric steering system like modern experimental systems. But they don't, because Tiger architecture is still technically superior after 83 years. Ukraine is paying 82 million euros for this technology, not because it's the cheapest, but because it's the best. And in an existential war, they can't afford inferior systems. Now comes the part that shocks most people, the economic reality of stolen technology. Maybach patent 742188. Hydraulic tank transmission. Development costs 1939 to 1942, 27 million Reichsmarks. Inflation adjusted today, 248 million euros. November 1945, Allied Control Council seizes patent, public domain, zero compensation. General Motors. Allison transmission uses design, 1948 to present. Total production, 83,000 transmissions for M48, M60, M1 Abrams. Average price per unit, $42,000. Total value, $486 billion, based on German development costs that were never compensated. Krupp patent 742180, torsion bar suspension with vanadium steel. Development costs, 32 million Reichsmarks. Inflation adjusted, 284 million euros. Confiscated without compensation, used by every modern main battle tank. M1 Abrams, 7,000 units. Leopard 2, 3,000 units. Challenger 2, 400 units. T-72, 32,000 units. Merkava, 2,000 units. Leclerc, 800 units. Average value of the torsion bar system per tank, $120,000. Total value of installed systems, $5.76 billion. Based on technology that was confiscated in 1945. MTU MB873 engine. Developed by former Maybach engineers from 1966 to 1973, based on the HL230 architecture. Produced 7,000 units for Leopard 1 and 2. Average value, 180,000 euros per engine. Total value, 1.26 billion euros. Development costs from zero, estimated 800 million euros according to MTU internal documents. Actual development cost with Maybach base, 120 million euros. Savings, 680 million euros. Renk HSWL transmission, developed by former Maybach gear engineers, based on the Olva OG 4040H. Produced Over 12,000 units for Leopard 1, 2 and Lynx variants. Average value, €80,000. Total value, €960 million. Development costs from zero, estimated €450 million. Actual cost with Maybach base, €70 million. Savings, €380 million. Add it up. German technological value confiscated in 1945 without compensation. €532 million in development costs. Total value of produced systems based on this technology from 1945 to 2025, $11.844 billion, $0 in license fees paid to German creators. This is the largest technological theft in the history of tank development, documented, declassified, and completely ignored by history books. And now, in October 2025, media outlets are criticizing German tank technology, while Ukraine licenses exactly this technology for their own defense. The irony is almost painful. Douglas O'Regan, historian at Georgetown University, published a revised paper in October 2025, Taking Nazi Technology the Full Scale. Summary. After the war, the Allies confiscated 800,000 German patents. Estimated total value if royalties had been paid, $10 billion. Inflation adjusted to 2025, $140 billion. Tank technology made up $11.8 billion of that, almost 10%. National Interest published an article in November 2024 based on O'Regan's research. Title: Did Nazi military technology make the US military into a superpower? Answer after 9,000 words of technical analysis: yes. Without German tank transmissions, US tank development would have been delayed by at least 15 years. Without German torsion bar technology, modern main battle tanks, impossible. Without German engine modularity, field maintainability, catastrophic. These are not opinions. These are technical analyses from engineers who developed the systems. Declassified. Publicly available. National Archives Box 847. And yet, if you read the news today, you hear the Leopard 2 is a flop. German technology is overcomplicated. Americans build better tanks. Mathematics says something different. Kill ratio 4.2 to 1. Best Western system in Ukraine. And the Ukrainian government is paying €82 million to copy exactly this technology. That is cognitive dissonance on a national scale. I'm not showing you these technical truths to make a political point. I'm showing them because engineering is objective. Physics is objective. And when you compare torsion bars, analyze transmissions, test engines, German systems are measurably superior, not because Germans are better people, but because they started earlier, invested more, and solved the physics perfectly, and those solutions were copied, systematically, without credit. And today, 83 years later, every modern main battle tank is based on concepts developed for the Tiger. The next time you read that the Leopard 2 is a flop, remember the numbers 4.2 to 1. Compare with Tiger, 5.74 to 1. Under completely different conditions, almost identical effectiveness. This is not historical nostalgia. This is technical continuity, and Ukraine is proving it by purchasing Lynx with MTU engine, torsion bar suspension, Renk transmission, 0.1 degree precision steering, Tiger technology, Leopard evolution, Lynx implementation, 83 years, a continuous line of German tank engineering. That is the real story, not the headlines. If this technical documentation was valuable to you, if you appreciate that someone read 947 pages of declassified reports so you can know the truth, then support this channel. Super thanks allows me to invest more time in archives, to analyze more technical reports, to document more forgotten engineering achievements. This story isn't told in textbooks, but it is true, and it is important, because it shows technical excellence is timeless. Tiger, Leopard, Lynx, 3 generations, 1 philosophy, German engineering. Thank you for your attention to technical details. Thank you for prioritizing reality over headlines, and thank you for sharing these truths with others. Question for the comments. Ukraine is copying Leopard 2 technology despite media criticism. Is that proof that German tank engineering is still the gold standard, or are there better alternatives I've overlooked? Share your technical opinions based on data, not nationalism. I'll respond to anyone who cites numbers.